welcome to another episode of Application Development Today. My name is Don Jackson. I'm your host. I'm also a chief technologist here at Micro Focus. In today's topic, we're going to be talking about accelerating your world with containers and CI. And I'm pleased to have with me today Mr. Jason Harabi and Mrs. Kelly Gundler.
Hello.
Kelly, if you want to introduce yourself real quick.
Sure. I am the ADM, Application Delivery Management Practice Manager here at OpenText.
And Jason?
I am the lead developer of our Nimbus demo platform. I'm also just a regular DevOps engineer trying to live my best life. So there you go.
So thanks, guys, for coming in and doing this session again. That's an inside joke. If you guys ever want to know, you feel free to reach out to us. So the reason that I've asked these two people to come here is because Jason is essentially our lead developer, lead architect for our Nimbus platform that we leverage for demos here in pre-sales here at OpenText for application delivery management. And Kelly, as the practice manager, is essentially the customer to Jason, right? So I wanted to have this dynamic of developer and customer and end user dynamic to really convey what the benefits really are from leveraging containers. So first off, I think it's good to kind of talk a little bit about Nimbus when we talk about Nimbus and when we're talking about this so that people can understand what it is. So about 6.5, maybe 7 years ago, we used to have a demo image that was this giant VM that had every single thing installed on it, including every server-side application, every client application, and we'd get a new version of whatever it is, and we'd have to completely rebuild it. Everything was installed manually. Fast forward to today is the server side stuff is all delivered via containers. The client side stuff is now automated and automated builds that Jason, I loved doing, I'm sure, Nimbus client automation.
Yeah, I don't do the builds. That's what the robots do.
Yeah, that's what the robots do now.
That's what automation is for.
Exactly. So when we say Nimbus, that's what we're talking about. No, we're not talking about the Nimbus 3000. We're not all riding around on wonderful brooms from Harry Potter. That's not what we're doing here. So Kelly, I want to jump first to you and kind of talk about the benefits of containerization and continuous integration, continuous delivery, because it's really a combination of the two that's led to the I don't use the term lightly, transformation. I mean, this was really transformative. Mm-hmm. What's been the business benefit from a customer perspective? Because you're the customer in this scenario.
Yep. So, well, there's a bunch of me. I'm in pre-sales. So our role is, working with customers to help them with, show them our solution, work on, pilots and proof of concepts and things like that. So there's many people in our group worldwide that do this. And I think you touched on it already a little bit, Don, that if you go back to the olden days when I started in pre-sales decades ago, actually, we tried everything, and you can see it, go with time. In the beginning, we would just get out the CDs or diskettes and install it right on our computer and, try to keep it up and running. But you could only do that with you're not going to run a bunch of servers and things like that. We could kind of do that with client software. And then we kind of evolved. We get bigger machines that had big enough drive. We could maybe partition things off. That was kind of a next best step. But you still be plagued with, size and updates and keeping it all running together. It was kind of an ongoing nightmare. And eventually we got to the point where we made the VM, and we would have this sort of, gold standard VM that had every single thing running with every scenario we would want. And that was probably a milestone in benefit. But it was a big kind of monolithic thing. So when you would need an update, you'd have to get the whole thing again. Well, our portfolio is enormous. We have tons of products and tons of updates. And so to download this gigantic VM anytime there was an update was time. It was slow. It meant anything that you had done customized previously was gone away. It's not like you could keep multiples of these running. So it has, I would say transformative is actually a really good word. With containers now, we get the bits we need when we need them, nothing else, and lots of other benefits we'll talk about today, but it has definitely changed the way we use it and other partners inside the organization for various reasons we'll touch on as well.
Awesome. Thanks. So let's just jump right into this. So who wants to volunteer to explain to the audience what is a container? And by the way,
I think Kelly wants to do it.
and then Kelly points it on.
Actually, I'm pointing to Jay. I'm pointing to Jay.
Our cameras are going different. So.
Yeah, our cameras are going every which way.
We need to practice our Brady Bunch moves ahead of time so we know our layout.
Right, that's right. So, Jason, okay, so it was punted to you, right? So can you kind of explain what is a container? How does that differ from a VM, and what are kind of the advantages of delivering something in a container, especially in a CI environment or continuous integration environment?
So to kind of continue the theme of what Kelly was talking about before, where you were installing software directly onto the machine.
By the way, I have to jump in and interrupt, Jason. You have that Toronto's Maple Leaf thing in the corner, and as a huge Red Wings fan, I really have a problem with this. I don't know if I'm gonna be able to invite you to any of these in the future.
Okay, well, I mean, I don't want to date this podcast too much, but there might be an important sporting event going on today, so that's so. Hey, look,
you just rub it in. Okay, no, that's
it's
fine.
not like the Leafs are a threat to anyway. We're our own worst enemy. So, I like misery, so that's why I've chosen that. All right, back to
the question. Now that I've derailed the entire
let's bring it back. That's okay. Okay, so yeah, so the first attempt to deal with that problem of trying to install software directly on your laptop was through virtual machines, right? So we would create virtual machines and we would jam all the software on there, and it became a delivery device for sending out the bits everywhere they need to go. Now the main problem with virtualization in that sense is that the hardware level has to be simulated when you're creating when you're using VMs, right? So when you're using VMware or VBox or whatever you're using, it's simulating the hardware directly from the hardware that exists, right? One of the main problems you would find is that because people's hardware was so drastically different, right? You don't know what laptops different people have or what they're running it on. You would see different performance issues all of a sudden pop up, right? You might just see the machine not turn on certain services just because it didn't have the hardware that the VM was created on, right? So that brings us to containerization. And one of the primary benefits of containerization is we're not having to virtualize the hardware level, right? The container is all software based, right? And why that is beneficial is because the primary benefit is that the container should run the same regardless of the underlying hardware. Now, again, you'll have potential performance issues, right? If you don't have the right amount of RAM, the disk speed is slower. You may see performance issues, but the application should run identically. And that's what we need, right? We need to be able to issue out to all of pre-sales using this container, as well as people who are using it for training, customer service, whatever the purpose they're using it for. We want to know that the application is working the same. And that's what it gives us. It gives us the ability to ship out a known state application to the various users. And that's really the primary benefit that we get from containers.
So you think about this known state, right? So as you know, and people who've watched the series understand, right? I cut my teeth back in the 90s as a software tester, right? And invariably we would write up defects, and I don't remember what the percentages were, but I would guess that it was probably greater than 40% of software defects we would write up on our applications would be attributed to environmental problems, right? That the stage environment or the test environment or the UAT environment, whatever environment we're doing on it, this configuration wasn't pushed out, or architecturally it was different in this manner, or whatever the case would be. And we ended up wasting a bunch of time. So speaking about value stream management, right? Waste is an important term, right? Wasting a bunch of time. And how do you mitigate that waste? Well, we would try things like, okay, so we're going to try to replicate the environment. Well, when you're talking about a production environment, especially where I was at the time, an AS400, I'm not going to have, 24 AS400s in my lower environment. That's just insane, right? At the cost of each one of those, could potentially be seven figures. It just wasn't going to happen. So you ended up having all this waste of time. So being able to deliver and know that your application is going to run the same in these different environments is absolutely huge, not just for pre-sales, but I think for anybody who does software. And one would think everyone who's watching this knows something about software and is living in software.
Well, so I want to point out two things about what you just said there, Don. One was from a QA perspective, finding those issues, but you could only find them if you had the right or the wrong environment, I guess, depending on how you look at it. But then there's also mitigating them from our perspective. In my role, sometimes it's not about us finding a problem. We just need to be able to show it to a customer that we can be documented or whatever. And so in those cases, if we didn't have containers to get it to run, maybe I want to pull it down and run it in my environment, but my laptop, this problem, my laptop, that version issue, whatever, the only way to get around that is then to fix it. Where with containers, you don't have to. I mean, it's a product issue. We need to document it and, say it doesn't support or does support in this environment. But with containers, then it doesn't have to be fixed. It is contained and predictable. We don't have to deal with that even to get it out into the, the job that we need it for. So it's two-sided on that for sure.
Yeah, I mean, one of the main benefits too is making sure that like I said, back to known state. What are some of the issues that can appear on having different environments, right? So environment variables, not having the dependencies already installed and ready to go, right? You might have a slightly different version of Java on one machine than the other, right? Well, okay, who knows what problems arise because of that minor difference. And nobody might have even thought about that. It might come back while you're trying to debug the thing, right? So having known state, right? Knowing the bits that are on there, and that, like I said, includes environment variables, dependencies, any other software that's in the container, that is a very powerful tool across our organization, right? From pre-sales being able to show the applicant, because quite frankly, pre-sales doesn't care how they get their hands on the bits, right? They need to get it quickly because we want to show our customers the latest and greatest software, right? We don't want to show them 2 or 3 versions back, and they need it to work, right? And they don't want to jump through hoops trying to get the software up. They just want it up and running. Right?
It just works. Well, and that's what we always say, it just works. And even to that point, Jay, even again, if you look back in time, it's like, okay, here, get this image, a VM or an installation. And now, even if we put together a nice set of steps, make sure you have this environment variable, make sure you set this path, make sure it's still extra work. And so to be able to confidently say, and I don't know how many times myself or other people on the team have gone in with blind faith right ahead of a meeting, like, ooh, I got this meeting on short notice. You pull down an image and it's just going to work. Those things are done. So being able to deliver in its final functioning state without any extra steps, even known steps, saves a lot of time and worry. I mean, anytime you have to start tinkering, there's issues potentially, right?
And it eliminates that well-known saying among developers, well, it works on my machine, right?
La 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 la.
Yeah, exactly.
And again, we have all lived through that before, right?
Yeah.
Where the developer is frustrated because, quite frankly, he doesn't know why your installation is messed up because you installed the software differently, right? This is why we have the entire concept of DevOps, right? Because, devs would ship their stuff up to ops and they would both yell at each other because clearly it was the other group's fault that this, right? Right? Pointing wherever we're going. It's everybody's fault but your own, right? And that's why the concept of DevOps came around, right? Containerization came at this perfect time during the CI CD DevOps phase, right? Where we wanted to be able to ship the application from devs to ops. We wanted them working in tandem. Well, now you have this smaller deliverable that should be able to ship from ops directly into whatever environments it's got to go to, and be deployed and begin working. And it should be exactly the same, right? So as Don alluded to before, right, from a testing perspective, that has to work, right? We don't want QA wasting their time trying to stand up the application, right? That's not their job. Their job is assuming that we have a stable application and they're just going to jump in there and find the problems, right? And because we as dev know exactly what QA has, we should be able to simulate the problem in the application almost exactly. Now, there's limitations, right? In our environment, in our demo environment, we use an anti-pattern of not using volume mounts. Volume mounts are there generally to keep data persistent, right? So when the container dies, the data still exists so that you can bring a new container up. To allow us to have truly known state in a demo environment, we jam the database inside the actual container. That's a no-no in production, obviously. But again, it allows us to quickly get an application up that we know has known state because we know what the database is, and the database has to be populated, right? The applications, most of our applications are useless if we don't have data in them already, right? You're going to look at a bar graph and it's going to go like this. And it's going to be a very...
patient died on the table.
Yeah. Well, it's true.
Right?
It's an anti-pattern for a production deployment of the software, but it's the exact right pattern for us in what we need, right? That known state. Yeah.
But anti-patterns aren't necessarily... They're just against what you would traditionally see in... other environments, right?
Typical
And we're well of what the best practice is. We're well aware that we've gone against the best practice for a specific benefit, which we're gaining, right? So, and again, everybody has to look at the benefits of why they are creating the container, right? What is the purpose of the container you're creating, right? Because R&D may create a container that has this very anti-pattern in it for their test purposes, to send a data-filled container to other groups to say, okay, for just to assume that we already have the data, or they may put the data in a separate container that doesn't have a volume mount. So, okay, we know this is a known state data, because how are you going to test if you don't know what the known state of the data is, right? So,
well, I think about live. I shouldn't say live. Programs that I was working on where, we had many cycles of testing because, we were implementing brand new software, right? So we get a build of the software. We have the golden copy of the data. We load the golden copy of the data back from tape, which have you ever loaded something back from tape? Oh my gosh, right? It took forever, right? You'd have a complete cycle reset, and then you'd run your tests, and maybe you were running, Lord forbid, you're doing a performance test that consumed that data. Okay, so I'm running, maybe
hopefully someone's got a backup,
a couple million transactions per hour, and I run that for 3 hours, in order to test it through. Oh, we find a problem, we got to send it back. Well, now what do we do? Oh, well, we got our 2-day restore that we got to do in the lower environment. Sorry, it's going to take forever. If we had, using your example, if we had a container, if we had containerized that data for the purposes of testing, I'm not talking about in production, but for the purposes of testing, now I could just revert back to that. I want to drill down in, though, to something that Kelly mentioned earlier. And Jason, you've talked a little bit about as well from a benefits perspective. And that's talking about speed, right? Why? And I'm throwing a softball up for somebody to hit here. Why is it, if I've got, version 1.0 and I get a version 1.1 of the container, why does it seem like it's so much faster to get version 1.1 of the container up and running?
So again, it'll
I'm looking for the word layers.
I know you're looking for the word layers. I'm coming to it. Yeah. No, I mean, and that's one of the benefits of containerization as well, is the concept of layering, right? So it's the containers are actually built upon what a lower software level, and then you go up and you go up and you go up. From a development cycle standpoint, because we're probably not changing the underlying OS level frequently, that saves us a whole bunch of time that we don't have to recreate using that layer, right? We may have updated that layer to get some updates to it. If those updates are already there, we get the benefit of having that while we're building the container. Remember, it's not just from a delivery standpoint that the layers are useful. They're also useful from a development standpoint because we're caching those layers every time we build, right? So Docker, I'm going to use Docker right now as the build example. We'll talk about other container development software later. But because if I'm not changing a layer, there's a caching mechanism, right? So it's not going to rebuild the same layer every time. If it took an hour to rebuild that one layer, okay, well, I've cached it, I've saved it, and now I can go on to the next part, right? Whereas I might have just changed just this tiny little part of my start script that happens at the end of the layer. Well, now instead of taking an hour to build you a new container, it's taken 3 seconds because that's the only layer we've modified. And now I've shipped that back out to QA, and QA goes, oh, okay, we've got just this little change that we need to bring in now, and they're up and running that much quicker, right? So yes, the concept of layering from a build standpoint and from a delivery standpoint is also a very powerful feature of containerization as well, and it's an underappreciated layer sometimes from the end user perspective, but certainly for those who are developing it and shipping it, that they certainly appreciate that benefit.
Yeah. And I think too, when you start thinking about this outside of our individual use case in pre-sales, the deployment time, you go through this cycle, you're going through this rapid feedback, this constant feedback, this fail fast mentality. Okay, so I get a build, during a release, during a sprint, I get a build, I find this critical defect, I write up that defect, the developer who is working on it gets it and they go, oh, hey, I just need to change these 2 lines of code and I rebuild. Okay, I take that into a CI mentality, right? And I push out, I do a commit. My CI is looking at the commits. It now pulls that down, it builds it. Well, that speeds up the build, right? The initial build took 3 hours to build. This build, because I'm only doing this one layer, now only takes 2 minutes to build, and I deploy it from a deployment perspective. I deploy that down, which is what we're doing, what Kelly and the rest of pre-sales are doing, right? How long does it take you to get a new build of the application as opposed to the first time? The first time it might have taken you, 20 minutes to download it, because we all have high-speed connections now. It takes 20 minutes to download it, whereas you get the next version of it and it takes a minute.
Sometimes not even that.
Yeah, sometimes not even that. And so the speed, we always talk about how do we accelerate things. using containers, I think I think we understate the value of the speed. So you talk about wasted time. Okay, yes, I could be doing other things. I could be reading my emails. I don't know. I could be doing my nails, right? I don't know. I could be doing lots of things, while I'm waiting for this to happen. But now I don't even have to wait for that, especially when you're talking about an emergency fix situation, system down event, something like that, a Sev1 environment issue. That speed to fixing it becomes absolutely crucial.
Well, I think also not just the speed in the build or the pull down is, but also the speed in diagnosing and root cause analysis, right? So like you said, Don, in QA, if you find 40% of the issues are related to environmental things, we already know that's pretty much not it. Like we've already chopped off a huge amount of time in what we can take out as the variables. But also passing it to the right people. Maybe we find that it has nothing to do with Nimbus or a conflict or something like that. We know it's not environmental because we all have the issue or we don't. But even passing our containers, which are for our own purpose, onto our product R&D team, being able to recreate things is really quick. So there's time saved in all different areas of this.
Yeah, and if you extend that further, right? So now I've got my container that I have this known state container. And by the way, if you change something in it for whatever purpose you do, right, you can commit off that container and you can deliver this whole environment. Here you go, R&D, here's the problem. And oh, by the way, I was using my wonderful OpenText solutions to do my automated testing. And here's the test that you can run in that same environment to reproduce the issue. And you could just watch the issue happen, right? I don't have to do a recording and send this huge, AVI file or MP4 file or MOV file over to them, to show the recording. They can just reproduce it, and they can reproduce it at will. I think that becomes hugely valuable, not just in our environment, but for anyone who's really watching this. That becomes environment. So, Jason, you talked about, you alluded to other types of containerization technology out there. So what else is there besides Docker? I mean, you've mentioned Docker a few times, and a lot of people use Docker and container synonymously. Is it the same thing?
No. No. I feel like another softball just got lobbed to me there. I'm
really good at that. I would not be a good
perfect. It's good because I never played softball as a kid. So if you could just throw it under.
You're making up for that time now. Yeah.
So the reason why Docker and containers became synonymous was because Docker drove the popularity of containerization, right? They made it well known in the space, even though the concept of containerization had existed for decades, and in the Linux world, it had been created. It just wasn't adopted at an application level containerization like it is now. But with the rise of Docker came the rise of popularity in containerizations, and again, they were the first to market, so they became synonymous, right? It's like, why do we use Band-Aid instead of adhesive strip? Why do we use Kleenex instead of tissue, right? Yeah, exactly, right?
Xerox.
It becomes Xerox, right? Exactly. I'm going to Xerox something. So,
how long has it been since you said that, though?
The word Xerox. Wow.
Yeah.
It's all this white beard, right? A lot of my cultural references are like,
little dated.
That's a little dated, Don. Good job. Let's talk about Gremlins.
Hey, nothing wrong with Gizmo, okay? Just let's go with that. Okay, so back to the content. So Docker became popular. Docker is still popular, right? As a container engine, it still has a large market share in it. And again, part of that is because it was open source for so long, right? And still the community edition still is open source, right? Tooling was developed by open source communities to make it as powerful as it was, right? Microsoft in Server 2016, if I'm got my numbers correctly, or it might be 2019 now. I'm concerned I have the wrong version. But anyways, they adopted Docker into their actual platform, right? Docker became part of the Microsoft server deployment, right? Which was huge, right? Because once you're part of the Microsoft environment, you're doing pretty well, right? So that's where we got Windows containers from. But from a software technology, what is out there as far as containers is concerned, it really depends on what your needs are, right? Every bit of software has been created to support containerizations, right? We have things like monitoring software like Portainer or something like that, where you can get a graphical view of what you have deployed, right? Because, for those of us who don't mind using the command line, it's great, right? We just continue to use our command line as we normally do. But some people need a more visual representation of what they're seeing, right? From a deployment perspective,
So I'm thinking Windows versus DOS now. Okay. I'm going back to those references.
Don is killing me with the flashbacks today. He's going all
I'm going to throw up a reel-to-reel next.
There you go.
Punch card. Go.
From a deployment perspective, though, things like Docker Compose got created really early on, right? When Docker first came out, it was great, but you had to, write a giant command line command that was going to start this container up with your specific needs for it, which was fine. But what if I have 2 containers? What if I have 3 containers? What if I have an application with 12 containers that all have to go up? So Compose came about as a way of documenting, how I want these containers come up, which container relies on which other container, because you may have dependencies, right? You need your database container to start before your application container comes up, and various different other requirements. And you wanted it documented because, again, the power of containerization is that they really follow that microservices architecture, right? If you're following best practices, you have a container for every small part of your application, right? You've got your Elasticsearch in one container, your database in another, your main application might be running in a third or fourth. So that's where Compose really gave the benefit to us. But then all of a sudden, that was fine for developers building their application right where they were. But okay, well, as these containers started to become more and more popular, and people are like, okay, we'll put it into production. We want to put our application in a container into production. The Compose methodology just wasn't powerful enough, because in our microservices architecture, we wanted to have load balancing. We wanted to have auto healing applications. And that's where you start seeing the rise of orchestration software. So you've got really 2 that you mainly hear about. The king of containerization orchestration still remains Kubernetes. Kubernetes was born from this orchestration requirement. It is, to this day, it is still a complex piece of software to use. Now, it has gotten much better over the years. When it was first introduced, its power was obvious. People wanted to use it, but you needed to be really needed to be down in the muck with knowing how to do a Kubernetes deployment.
Which Jay
again, I would say that Kubernetes, when it first came out, was well beyond. I remember taking a course on Kubernetes. Because
I feel like I'm taking a course right now.
But again, they would describe that our teacher in the course described what the test was, which essentially was, we're going to give you a broken Kubernetes deployment. And you have to go through the Kubernetes deployment configuration. And as you get things right, there'll be this little green check mark list that'll start popping up saying you have solved these problems, right? And you would see everything is in red. And your job was, in an hour, look at the Kubernetes configuration and figure it out. And, it had a first time pass rate, I think he said, of about 20 to 25%.
This sounds like the certifications that I used to have to do back in the day with Load Runner and Test.
This was to become Kubernetes certified in 2019, right? So as things evolve, again, right, it's great. It was great for production and development deployments, but it wasn't at that level where you're just going to throw it to your brand new fresh developer and say, okay, make this Kubernetes deployment, right? It wasn't there. They are trying and continue to succeed at making it more user-friendly, because honestly, the developers want orchestration too, right? I should be able to deploy my auto-healing application, scaled down, obviously, but on my desktop with the same Kubernetes configuration. Now, if you want to go one step, let me take a step to talk about Swarm before we go anywhere else. But Docker Swarm was Docker's attempt, and it exists still today, but at making a more integrated Docker orchestration configuration, right? If you deploy Docker, you can easily deploy Docker Swarm in your environment, and some people are happy to run Swarm as their orchestration engine. But again, when you're becoming much more powerful, much more scaled up, Kubernetes still remains the number one software out there. But again, like any new technology introduced, right? So Docker required us to have orchestration software to have Kubernetes. Well, then all of a sudden we realized, well, wait a minute, I want to deploy this Kubernetes configuration, but in UAT, I need to scale it down. I don't have the hardware. I don't need full scaling out. And the configuration is going to be slightly different in UAT than it is when we put it into production, right? Okay, well, how do we deal with that? So then people came up with Helm charts. So now you've added a new technology level. And Helm basically allows you to have dynamic Kubernetes configurations per environment. So now you've stacked new software upon new software upon new software, right?
7 dimensions.
Right, 7 dimensions of new software.
Jay,
right?
I'm just curious, what made Kubernetes so hard? I mean, it seems like, in my experience, configuration software is always complicated because it's configuration. So, the possibilities are limitless. Is that what made Kubernetes difficult, or difficult, but complex?
That's part of it, but again, it's the sheer number of options is part of it, right? But the language in which it was written, I'm going to say the wrong one, and somebody will comment and say, no, you're absolutely out to lunch. But if I remember correctly, it used to be YAML, which YAML is not my favorite language for configuration in any way. But it was flexible.
Anybody who's ever had to configure a YAML file, big one,
yeah,
and you got an extra space somewhere, and you're trying to,
this is why we have this is why we have YAML linters to tell us where our space is wrong. But yeah, it was the sheer amount of configuration options that you had, and it was so low level to what you were wanting to configure, right? It was like, it's the difference between, assembler and, Java today, right?
So no,
when you're doing assembler, you're in the gut, you're in the guts, right? And that's where Kubernetes started, right? And again, right, like any language or any configuration tool, people inevitably go, this is great, but now I'm going to make a script, or I'm going to make this piece of code to make it easier, right? And over time, those tools become accessible to the community. Now it's an easier tool. And I think like any of those tools, they will just become simpler to use and deploy, right? And then eventually you're gonna, just go and chat GPT and say, okay, make me a Kubernetes deployment file that deploys X, Y, and Z, right?
Well,
And it will only be half wrong. It will only be half wrong.
Yeah, well, that's the key right there, right? So just like as the world is learning, right? So chat GPT and others like that, you have to be a good proofreader, okay? You can't just implement what comes out of that, because sometimes, maybe half the time, it's wrong. And it says it with such confidence. Yes, it says it with such confidence
wrong.
that the expert's like, wait a second, do I misunderstand this? And you start doubting yourself.
It's gaslighting, right? You. It's like a moody teenager.
It is. It's like being gaslighted. Oh my gosh. So we've talked about, kind of where we were. We've talked about where we are today, how things have really transformed. So where do you guys think that containerization is going? Where do you see, and I want to ask you, Kelly, from a business perspective, right? Because you're the customer in this scenario, right? Where do you think this is going, right?
Well, hopefully, maybe this is a hope and not a prediction, but just to
Jason's taking notes so that he can and get developing on this.
Exactly. Something that has
$1 million idea. Give it to me right now.
Yeah. Hey, if I had that one, I think just more abstraction, more, I assume more people seeing opportunities where they can build packages to go on top of this that help, me and others do their job using this as a foundation, but with abstraction related to what we want to do to make it just so easy to use it. Continuously evolving what it can do, but who it's accessible to, who we need to be able to benefit from it, I think is the direction it seems to be headed, at least.
So using containers to shift everywhere.
Oh, sorry. Man, well played.
So Jason, from a
shameless plug. You
shameless plug there, right?
For that?
Yeah. We'll have production guys. So blink. So from a technologist perspective, so as an R&D person, Jason, what do you see changing from a containers perspective in the future? I think we
Jason
may have lost
frozen,
Jason.
Or he's super deep in thought.
I think Jason is saying that, he's just going to, make the world happen. Well, I think we've lost him, but the only thing left down on my agenda was as I wanted to give a chance for parting thoughts. So Jason has foregoed his parting thoughts. So Kelly, I'll leave it to you for parting thoughts on containers and CI.
I don't know if Jason was ever really here. I think this was just an AI version, and you can see the second half is failing, but making it feel like it's our fault. I think that's what's happening. So closing thoughts, it has changed how we do our work, even though we weren't probably the intended consumer of this. So it's improved in every aspect of how we use it. And I think that what we've learned and what we've gained will continue to build on going forward.
Yeah, and I couldn't agree with that more. The containerization has revolutionized how we do our jobs, and I think about how before I came to OpenText, how it would be revolutionizing my job there to be able to, like we talked about, to be able to quickly deploy into a known environment. And like I said, it may have been more than 40%, but I would guesstimate about 40% of the defects that we run into were strictly environmental challenges. If I could take that out and not have that wasted time of these, because it wasn't just me as the tester's time, it was the developer's time. The developer's trying to reproduce this issue. It was digging into it. Now I got to go grab a DBA. I got to go into this. Oh, you know what? I need to go grab the Linux admin because maybe it's something in the kernel, right? We have different versions of the kernel because we didn't have isolated environments. That was just absolutely an absolute time saver and making me more productive. So I think we may have gotten Jason back that he can give his parting thoughts. Maybe not. Well, I want to thank everyone for coming in. Excuse the connection issues. Oh, is Jason back?
Kind of.
I think he might be using dial-up now. And AOL, you've got mail.
It's a salute to you, Don.
Yeah, he wanted to make one of these references. Well, thank you, Kelly. Jason, if you hear me, if you get the smoke signals that I send your way, thank you for joining us today. And I look forward to the next episode that we're going to have. The next episode, we're going to be talking about chaos engineering. So chaos testing, chaos engineering, and introducing chaos into your life. Well, your application's life, at least. So I look forward to that, and I hope you enjoyed the session. Have a great rest of your day.
Thanks, Don.
If you liked the video, please click the like button. And don't forget to subscribe to our channel so that you get notified when we release new videos.